Let's have a look at some examples of one-step equations. And the goal of these, solving an equation is to make the symbol that you want to try and find the value for the subject of the equation. You want it to be on its own, on one side of an equal sign. Normally that'll be on the left-hand side, all right? So with one-step equations, we're going to reverse the equation in such a way that is to rearrange. We're going to rearrange the equation in such a way to make the unknown symbol on its own, okay, by itself on one side of an equal sign. So let's have a look at the first example. So part A, we've got a square plus 5 equals 13, and we want to try and find the value of this square, okay, a number that goes inside that square. So when you add 5 to it, you get 13. All right, you might have seen these in primary school. Okay, so they sometimes use different shapes, circles, squares, triangles, for example. What you've been doing, even in year 5 and year 6, you've been doing algebra. You just have not been using letters of the alphabet to represent unknown values. Okay, that's the only change. In fact, if you change these symbols and put shapes instead, so for example, 6 triangle equals 42, or 6 times triangle equals 42, and you want to find the value of the triangle, there's really no difference between that and using a letter of the English alphabet, or really any symbol you like, for example. Okay, so algebra can be quite fun. You can use whatever symbols, okay, come to mind to represent an unknown quantity. Square plus 5 equals 13. So my favoured method is we want the square on its own. So we've got this sort of plus 5 that we want to move over to the other side of an equal sign. Okay, so remember that an equation is a statement of equality. All right, so it's two things being equal to each other. Something on the left equals something on the right. But the thing we want on the left is just the square by itself. Okay, so leaving the square by itself, okay, equals, now the 13's okay where it is. I don't mind it being there on the right hand side, but the plus 5 is on the wrong side. We really need the plus 5 to be on the other side. But when you take something from one side of an equation to the other, you must do the opposite of the current action. So if the current action is adding 5, when we move that over to the other side, okay, the plus turns into a minus 5. Okay, so 13 minus 5, therefore, so these 3 dots here mean therefore, mean sort of like a concluding statement. Therefore, square equals 8. Now, go back to the original equation. Okay, you should do this with every equation. I would say that highly recommended, right, that you test your answer. Put the 8 back for the unknown symbol, substitute it back in. 8 plus 5, well, that's equal 13. I think we're pretty okay with that. Let's have a look at part B. 6x equals 42. 6x, when you have a number followed by a pronumeral, really what that means is 6 times x, or 6 multiplied by x, equals 42. Now, the 42 is okay where it is. It's fine. It's on the right hand side. I'd like to throw all the numbers to one side and the pronumeral to be on the left hand side. So the thing that's not in the right spot is the 6 times. Okay, so 6 times x, x times 6, doesn't really matter which order you put them in. This multiplication by 6 needs to be on the other side. But remember, when you take something from one side to the other, you reverse the operation. In other words, the opposite or the reverse of multiplication is division. Okay, so let's leave the x here on the left hand side. So that's cool where it is. Let's leave it there. We've got the 42. This times 6, not wanted there. Needs to be on the other side. So we're going to turn the multiplication into a division, and it becomes 42 divided by 6. Therefore, x equals 7. Go back to the original equation. Test it. 6 times 7, 42. I think we're happy with that. All right. I think honestly, and that's one of the beautiful things about equations. Okay. I mean, they're very logical statements, but very easy to test as well. So rather than guessing your way through or thinking, I don't know if I got the right answer or not, go back, take the value that you got, put it back into the original equation, and then check. Does 6 times 7 give you 42? If it does, you know you got the right answer. If it doesn't, well, you got to go back and check what you've done. All right. We'll be doing this more often as we progress through this topic. Part C, n minus 5 equals 3. Okay. Now, what should we do first? Okay. Is the 3 in the right spot? Is it on the right hand side? Yep. I think we're happy with that. The pronumeral's on the left? Yes, we are happy with that too. But there's something that's in the wrong spot. This negative 5 or this minus 5. Okay, so leaving the n where it is, Okay. The 3 is okay where it is, but this -5 needs to move over, and instead of negative, what's the opposite of negative? Positive, or opposite of minus? Plus. Okay, so it's going to be 3 plus 5. Therefore, n equals 8. Now, let's go back to the original equation and test it. 8 minus 5, does that equal 3? Sure does. All right. So again, we're happy with that. So you can self-check. So even if answers are not provided, you can check these answers for yourself. Go back to the original equation. I want to start getting you into the habit of doing that. That is so critical. To me, it's not acceptable and not good enough to just, I guess, just blindly, especially with equations, just to blindly attempt an equation and just sit there and say, yeah, I think I got the right answer. No, we've got to sort of move beyond that now and say to ourselves, hang on a moment, there is a way we can check this. Take an extra 10 seconds or 20 seconds, verify your answer. Okay, so I think that's a really critical part of what we do, testing what we do to make sure that we got it right. Last one, part D. B over 4 equals 20. B over 4 means division. All right, now we can write it with the division symbol. B divided by 4 is equal to 20. All right, they're equivalent statements. B over 4, fractions and division are very similar. In fact, the division symbol looks like a fraction, doesn't it? You've got a fraction line, the vinculum, that's what it's called, with the 2 dots representing the numerator and the denominator. All right, B is the numerator, 4 is the denominator. All right, B is in the right spot, 20 is in the right spot. However, the division by 4 is not. So if we're getting a number, we're dividing it by 4, which means we're making the number smaller, and you're getting 20, we'd expect B, the pronumeral B to be a bigger number. Okay, so B is equal to 20. The division by 4, when you move it over the other side, it's going to become a multiplication by 4. Okay, notice that when you move from one side to the other, from left to right, okay, plus becomes minus, minus becomes plus, times becomes divide, divide becomes times. Everything is opposite, just switches. Okay, it's really, really nice. Actually, it's one of the most beautiful aspects of algebra, right? Just going from one side to the other, everything just switches over. 20 times 4 is 80. Does it work? Go back to the original equation. 80 divided by 4. Sure does. So we're happy with that. And that is how we do one-step equations. Okay, there are other methods. I'm not saying that this method is the best method. It is a method. To me, this is what makes sense, but you can use whatever method you like. There's also a balancing method and a backtracking method, and there's all these different methods that you can use. But for me, I like doing it this way, but use whichever way you think. If you've looked at it or you've learnt these a different way, that's fine, as long as you test your answer in the end. Okay, that is the critical part. Make sure when you get your answer, go back to the original equation. Okay, test it. Does it work? Yes, it does. Great. If it doesn't, go back and check your working out.